Multicolor 3D printing has boomed in popularity over the last few years, with filament management systems like the Prusa MMU, Creality CFS, and the Bambu Lab AMS making it so easy and accessible that anyone can do it. The main problem had been that for every colour change, the printer would need to purge the previous filament from the nozzle before it began printing the new filament, and this produced a huge amount of purged waste material, in some cases meaning that a 30-gram object could require almost a kilogram of filament. But more recently, we've seen this wave of widely available printers with tool head changers or nozzle changers, allowing multi-material printing with zero purge waste, such as the Snapmaker U1 and the Bambu Lab H2C. Now the issue is that we're still limited to only being able to print in the exact colour of filaments that we have and the amount of filaments that we can connect to our printers. 2D printers can typically print in more than 16.7 million colours, just using 4 ink cartridges: a cyan, magenta, yellow and black, and mixing the distribution of these colours creates the impression of a different colour when viewed from a natural distance. Over the years, we've seen experimental 3D printers which have tried to combine multiple filaments before they reach the nozzle, or even ones which have tried to inject or paint ink or dye onto the filament before printing, but none of them have worked well or reliably enough to reach mainstream use. Recently, we've seen a wave of people experimenting with a fork of the popular Orca slicer, known as Orca Slicer Full Spectrum, and printing the results with the Snapmaker U1. This uses dithering, printing with a very thin layer line and then alternating the colour every layer. When viewed from a natural distance, the eye will naturally blend these into a single colour. There can be a bit of confusion over what this actually is, and I've seen people referring to the results from the Orca Slicer fork as full colour 3D printing, which it isn't. This still pretty much limits you to printing in block solid colours, but as the name of the fork suggests, full spectrum, this gives you access to the full spectrum of colours without needing 16.7 million filaments attached to your printer. User Doom Tools on MakerWorld recently published a test example of this method, but rather than using the Orca Slicer fork, they manually produced it in CAD. A rainbow Easter egg that they produced by designing the egg and splitting it into 3 separate models, each representing the layers required for each colour. This only requires 3 different filaments: cyan, magenta and yellow, and when printed on the H2C, it produces an egg with 7 different colours swirled around it. Now, I was expecting the dither lines to be pretty evident when looking up close, but this is as close to perfection as this method could possibly be, and I am really impressed with the results from this test. The definition and clarity in the different colours it produced is well beyond what I was expecting. Now, the main catch here is that this can only realistically be done with a 3D printer with a tool head changer or a nozzle changer, as if this is done on a single nozzle printer, the purge waste produced would be astronomical. But even when printed on the H2C, because it requires very thin layer lines and has multiple colour changes on every single layer, printing this egg still took over 20 hours. There is, however, another glaring limitation of this method using current FDM printers. The egg, for example, is separated into layers that are approximately 0.093mm thick, and then printed at 0.08mm layer height. This is great for creating colours on the vertical walls of the print, but this egg shape was chosen for a reason, as this method won't really work on top or bottom surfaces or very shallow gradient slopes, as rather than relying on very thin layer lines, it will be restricted by the extrusion width of the nozzle. Even with a 0.2mm nozzle, the default line width is usually 0.22mm, which is over 2.5 times thicker than the required layer height to make this work. As a result, on these surfaces you would just get a stripy pattern rather than a true dithering effect. You can see this if we look at the bottom of the egg, which was all printed on a single layer. The colour mixing can still be achieved slightly by viewing one colour through the varied thickness of another, and you can see that a little here in the creation of the green on the bottom. But I think that may have been incidental, and I've not yet seen this fully implemented into the same workflow as the dithering. With the amount of people in the open source community currently experimenting with this method and having a lot of success, I'd be surprised if the mainstream printer companies don't roll something like this into their slicers workflow very soon, maybe even this year. You could argue, why would they do that? Encouraging people to buy fewer colours means they're going to get fewer filament sales, but they're already pushing printers which produce zero purge waste, and printing this in 7 colours on that doesn't use any more or less filament than printing it in 3 colours. A 30 gram print is still going to require 30 grams of filament, it just means you don't have to dedicate half your workshop to store it. Plus, people would still buy a range of filament colours for single colour printing, as printing an object in a single colour produced with this dithering method would take significantly longer than just printing it with one filament. Despite these limitations, this is an exciting development which is going to give us a lot more control over the look and styling of our prints. I'm excited to see where this leads. What out-of-the-box use cases could you think for this method? I would like to see how this could be applied for mixing different material types using the dithering method and maybe adopting different properties of the different materials. Let me know down in the comments. I hope you liked this video, and if you have, please do give it a like and subscribe if you aren't already so you don't miss out on my future 3D printing and MakerTech tips and tutorials. For now, and as always, thanks very much everyone, and until next time, happy printing. A huge thank you to my revolutionaries. Your support, both via your memberships and your comments in the community, keep both me and my channel going, so thank you. If you would like to join them, getting early access to my videos, some exclusive additional content, and a load of other goodies, including discount on my store, hit join below any of my videos. For now, why not pop on one of my other videos to learn something new or have some fun. Thanks very much everyone, and until next time, happy printing.